Today's objective will be to solve systems of linear equations algebraically using the elimination method. You can use the elimination method to solve a system when one of the variables has the same coefficient in both equations. Coefficient is the number in front of the variable. In this example, notice that I have underlined the 3 next to the y. 3 is the same coefficient in both equations. Just a quick note, the term that you choose to eliminate in your system of equations must have two things: the same coefficient and the opposite signs. All right, let's take a look at an example of using the elimination method. So I have the system of equations right here on the board. So 4x minus 3y equals 29 and 4x plus 3y equals 35. So before I actually start this problem, I do want to make a note, and in the directions it says solve by using elimination. What I want to do is remember that I need the same coefficient on the variables that I'm going to eliminate and opposite signs. So let me take a look first and see what we have going on. I notice my x terms both have a coefficient of 4, but they're both positive. We could come back to that if we need to. Now let's look at my y terms. I've got a 3 and a 3 as my coefficients on the y, and then I got a negative 3 and a positive 3. So in my mind, if I were just to use the elimination method, I can add straight down. So I don't have to manipulate or change any of these equations to solve this problem. So if I were to add straight down, what I get is 4x plus 4x is 8x, negative 3y plus 3y, those are 0, and then equals 29 plus 35 is 64. Now I can solve this for x, so I divide by 8 on both sides, and I get a value of x equals 8. Once I have my x value, I can choose either the first equation or the second equation to substitute this x equals 8 back into. Again, pick which one is better for you that might be easier. I'm going to stick with the second equation because there's no minus signs, there's no negatives, so that means less chance for me to make a mistake. So I'm going to choose this equation down here. So wherever I see that x, I'm going to replace it with 8. So we've got 4, x is now 8, so 4 times 8. Everything else stays the same. So plus 3y equals 35. Now I can solve this thing for y. So 32 plus 3y equals 35. So now that I have my y value and I have my x value, I can write my answer. X goes first, so 8, 1 would be my final answer to this system. Now it's time for you to pause the video and work on practice number 1 in your notes. All right, let's take a look at an example of using the elimination method to solve a system of equations. Here's my system of equations. It says use the elimination method, so that's what we're going to do. Just a quick side note, if you thought about using substitution, all these coefficients that are happening in the equations are going to cause some fractions. That's why elimination at this point is better and easier than substitution. So remember, you must have the same coefficient of the same variable and opposite signs of that same variable. So let's look at this system. I have put in pink those coefficients for y. They're both 3. So now my job is to change one of these positive 3 signs to a negative 3 in order to eliminate them. You can choose whichever equation you want to work with. I'm going to choose the second one. Okay, so I'm just simply going to multiply this entire bottom equation by negative 1. So I get negative 8x minus 3y equals 25. Now I can just bring that top equation straight on over. Okay, I didn't do anything with it, so I just carry it on over. Now I can add these equations straight down. So 5 minus 8, that's a negative 3x. 3 minus 3, that's 0, so I eliminate my y terms, equals 25 minus 19, well, that gives me a positive 6. Now I can divide by negative 3, and x is equal to negative 2. Once you get an x value, then you can choose which original equation you substitute negative 2 back in for x. Doesn't matter, makes me no difference. I'm going to stay consistent and use that second equation. Okay. Now that I have a value for x that I just found, I'm going to substitute that back into one of the original equations that I started with. Again, it makes no difference which equation you choose. Just choose something that seems easy to you. I'm going to stay consistent and choose the second equation. So I've got 8. Now it's x, so x is negative 2. Plus 3y equals negative 25. Now I can just solve this equation for y. Now that I've solved for y and have a value for y and for x, I can write my final solution as negative 2 comma negative 3. Okay, let's take a look at another example of using the elimination method. In the last example, we looked at just adding those two equations straight down because we had opposite signs and the same coefficient on that same variable. On this system, we don't have that. I do have the same signs on the x and the same signs on the y, but I have different coefficients. So what I need to do is either choose x or y to eliminate, and it doesn't matter. In this case, they're both easy. I do know, however, with the y's, which is what I'm going to choose to eliminate, I do know that the common multiple between 2 and 10 is 10. So if I choose to eliminate the y's, I'm going to make this 2y into a negative 10y. In order to do that, I must multiply that entire top equation by negative 5. I can do that in one step. So let me go ahead and distribute that negative 5. So I should get 15x minus 10y equals positive 30. Now that top equation is done. Now I can just bring over that second equation. Negative 5x plus 10y equals 30. Now I am free to add straight down because I have opposite signs, same coefficient on the same variable. So 15 minus 5, that's 10x. Negative 10 plus 10 is 0, so that's eliminated. And then 30 plus 30 is 60. So I get an x value of 6. Once I get my x value, I can choose either the original top equation or the original second equation to substitute my x equals 6 back into. Again, whatever's easier for you works. It doesn't matter. You should get the same answer regardless of which equation you choose. So I think I'm just going to go with this top equation. So I've got negative 3, x is now 6, plus 2y equals negative 6. So let me solve this equation. So I get an answer of y equals 6. Let's finish this solution out by writing my answer as a coordinate. So 6, 6 would be the solution to this system. Please pause the video again and work on practice problem number 2 in your notes. Next example, we're going to solve this system of equations by using the elimination method. So one thing I'm going to do before I just jump into the problem is look and see what's going on, what I have, and what my plan is going to be. So remembering that we want the same coefficient and opposite signs, let's take a look. On my A term, I have the same sign and different coefficients. On my B term, I've got opposite signs and different coefficients. So for me, I feel the easiest plan of working through this is to begin with eliminating my B terms because they already have opposite signs. So now I have to make them have the same coefficient. I know that one of the multiples of 8 and 5 is 40. So what I'm going to do is multiply the top equation by 5 and then the bottom equation by 8. This is going to give me that coefficient of 40 I need to eliminate the B terms. So let's do this off to the side. So multiply, I'm going to get multiplying the top equation through by 5, I get 10a plus 40b equals negative 40. And then I'm going to multiply the second equation through by 8. Okay. And I get 24a minus 40b equals 176. Now, I'm just going to add these two equations. I'm going to add them straight down because I have opposite signs and the same coefficient on my B terms. So if I add down, I got 34a. That's eliminated because it's 0. And then I get 136, solve for a. So I get a value of a is 4. Once I have my first value, I can choose either the original first equation or the second equation to sub that back into. So I'm just going to go with the top equation. No reason. I just picked it. So 2a, but a is now 4, so 2 times 4. And then everything else stays the same. Now I can solve this equation for b. All right, now I've got my value for A, got my value for B. We're going to write this final coordinates, A, comma, B. So 4, comma, negative 2 is the solution to this system of equations. Now I would like for you to stop the video and work practice number 3 in your notes.